I want to go over a couple of the problems that I assigned here on logical equivalences. There are also there's a review also for a quiz which is on the same thing, so you should also look at that. Let's look at 10D. 10D was the expression P or Q and P then R and Q then R. All this, so between big parentheses, implies R. That's and the question is, show that this is a tautology. Now, okay, it just, you have to know what the word means. What you have to do is quite simple. To be a tautology means that this is always true. So in other words, when you have made a column for this proposition, then it should contain all ones. Okay, so that's how it works, and so we just have to do the truth table now. P, Q, and R. It's quite long, so let me make sure I have everything. So one. What is this? 1 1 1 1 0 0 0 0 1 1 0 0 1 1 0 0 1 0 1 0 1 0 1 0. Okay. So we have all these components, and we have to, yeah, so there were extra parentheses here, just make sure that I wrote everything correctly. Okay, so let's start with each of the components, P or Q. That's the first one we need. And that is just a regular OR with these two guys. Well, regular, I mean to say it's with these two guys, so it's very easy. We're looking for zeros in both, and then we know that this would be false. So this is false in this case, but all other cases it is true. Okay. The next one, I'll do it in a different color, is P then R. So now we're looking for ones here and zeros here. So this would be an instance of that here and an instance of that here. Okay. So these are the two zeros, and everywhere else we get a 1. Okay. And then Q then R. Let's do that in a different color so that you can follow everything. Q then R. A Q then R is the same, but now we're working with these two guys. Okay, and again we're looking for ones here, where there are zeros in the other column. These are the only two that I marked, so that's a 0 here and a 0 here, so we get 1 1 1 1 1 1 1. Great, so what we have is now these three, but there is an and between them, between all of them. Unfortunately, we cannot do that. Can we do that at once? Yes, you can do this. If you want to do this at once, you can do that, because for an n to be true, all three have to be true. Remember, that's how n's are true. So you have to be careful when you do all three. With ORs, it's a little bit trickier. Okay, so be careful when you do this. It is safer sometimes to do the first two and then do the third and end that with the third. But I'm going to do all three at the same. So I'm saying, okay, when is this whole expression? So let me give it a color. This blue expression, the whole thing between parentheses, that's going to come here. When is this true? It is true if all three of them are 1. Okay, so we're looking for in this, and in this ones, all ones. So where is this? So this happens here, okay, this happens here, and that's it. Okay, there are not that many instances, so let's work them again. So with what happened? A 1 here, a 1 here, a 1 here, and that. Let's see. Oh! I had one extra row, and that's why I got myself here things that didn't mean anything. Okay. Right? Okay, yeah. So, and that means zeros elsewhere. Okay. And now we have to do an implication of this is now going to be my first column. So this is going to be the first column, and the second column is be the R. Okay, so I'm now talking about the complete guy. So that's the purple guy. I put this here. Okay. Okay, so I'm looking for ones in the, no, yes, I want to look when is this false. I'm looking for ones here that we have zeros here. Now, okay, this one, that's okay. This one, there's a one there too. This one, a one there too, and that's the only one, so nothing else has to be checked. And so this means we have a one everywhere. And this is exactly what it means to be a tautology. Okay, all ones. And if this would be all zeros, you have the opposite thing, that is the contradiction. Okay, there were other homework problems like that, but okay. So, and then the other problem that I assigned was 61b. Let's see, 61b. That was so we have a composite. We have here P then Q. Let me copy this, and P then not Q, and not P then Q, and not P then not Q. And the question is this satisfiable? So that means, is it not a contradiction? In other words, is there at least one, is there at least a one in the column of this guy? Now, it's quite a lot to do, but it luckily is only two variables, so P and Q. So we only have 4 rows, 1, 1, 0, 0, 1, 0, 1, 0. So what we need, P then Q. Okay, we know that is 1, 0, 1, 1. P then not Q, so we need not Q, but we also need not P. And just to be a little bit more organized, I'm going to just keep them in this order. So this is 0, 0, 1, 1, 0, 1, 0, 1. Okay, so we need this guy, P then not Q. So I'm looking ones here and zeros there. That is only going to happen in this top row. Okay, so that's a 0 then, and everyone else a 1. Okay. Again, it's an and of many things, and remember, an and of many things is going to be true if there is a 1 in each column. Okay, so I don't have to do them. Like, let's work out each of these. Not P then Q. So not P then Q. I'm looking now for we are talking about this and this guy. This is the second row, right? So we're looking ones in the first, zeros in the second row. This is happening exactly here. So we get a 0 here and then ones everywhere else. And then finally, the last one. This is a color I used already. What color have I not used? Purple. This guy, not P, then not Q. So this is now, what are the rows? Let's get rid of what we had here. Sorry. Okay, so not P then Q, not Q, so we're looking for ones in the first and zeros in the second, and next to each other, so it's easier to see. And we see this happens in this row, right? That's the only row where it happens, and everywhere else is a 1. Okay, so we have all 4 components, and now we're going to take the end of all 4 of them. That means we're looking for a 1 in every single of these columns. So let's make sure that we know which columns we're talking about, because there's too many columns otherwise. We are talking about the columns P then Q, P then not Q, not P then Q, and not P then not Q. These are the 4 columns, and we need a 1 in all of them. Now, that is never happening, right? So you see, this one fails to have a 1 here, this one fails to have 1 here, this one, they always, yeah, this is a 0, right? They always miss exactly 1, 1, so they are all 0, therefore, because they are not, so, sorry. So, here, this column is for this expression is all zeros. So this shows that this actually is a contradiction, and therefore not satisfiable. So no matter what P and Q is, you can never make this a true statement. That's what that means. Okay. Okay, so I'm not gonna do more homework problems. As I said, the review also talks about it. These are all variations on the topic of logical equivalence, okay? And basically, therefore, variations on making truth tables.